Good morning, dear children. Welcome back to the lecture of chemistry. Today we are going to revise hydrogen chloride from study of compounds. In this chapter, we are going to study the introduction, laboratory preparation of HCl, properties of HCl, chemical properties of HCl, typical properties of HCl, oxidizing agent and test. Now, the molecular formula of hydrogen chloride is HCl. Its molecular mass is 36.5 because hydrogen has 1 and chlorine has 35.5. So, its molecular mass is 36.5. The nature of bond present in HCl is covalent. As you all know that covalent bond is formed between two non-metals by sharing of electrons. Now let us see the history behind hydrogen chloride. Now in 1648, Glauber discovered HCl. In 1772, Sir Joseph Priestley he prepared it, and it was believed that it is made up of hydrogen, chlorine along with oxygen. Later in 1810, Sir Humphrey Davy he proved that HCl is made up of hydrogen and chlorine. Now the previous name for hydrogen chloride was muriatic acid. It was named as muriatic acid. Now, where does this hydrogen chloride occur? It occurs in free state, in volcanic gases, in gastric juices of mammals. It helps to digest food. Now, HCl is also present in human stomach and it helps us to digest food. Now hydrogen chloride is HCl gas, but when it is dissolved in water, it is called HCl acid. So hydrogen chloride exists in two forms, HCl gas and HCl acid. The setup shown in the diagram is used for laboratory preparation of hydrogen chloride. In this preparation, a round bottom flask is required for uniform heating. Whenever heating is not required, flat bottom flask is used. Now the reactant used here are sodium chloride. Sodium chloride is put in round bottom flask and you can see Thistle funnel. To Thistle funnel, concentrated sulfuric acid is added drop by drop. Lower end of Thistle funnel is deep inside the solution. If it is not deep inside the solution, the HCl gas which is formed will escape. So initially the reactant are heated, but it is done slowly. Now HCl gas is passed through the apparatus containing concentrated sulfuric acid. Here concentrated sulfuric acid act as a drying agent, and at the end we get dry hydrogen chloride gas. Here the temperature is maintained below 200 degrees Celsius. So whenever sodium chloride reacts with sulfuric acid, it forms sodium bisulfate and hydrogen chloride, and the temperature is less than 200 degrees Celsius. Now why sodium chloride is used? Because it is cheap and easily available. Sulfuric acid, it is non-volatile acid. Its boiling point is high and so it does not vaporize at room temperature. Secondly, sulfuric acid is dibasic acid. It has 2H plus ion. Concentrated nitric acid is not used in this preparation because it is volatile and may volatilize out along with HCl. If the temperature is maintained more than 200 degrees Celsius, sodium bisulfate is formed along with HCl. Now the temperature should not be above 200 degrees Celsius because the fuel is wasted. The glass apparatus may tend to crack and the sodium sulfate, it forms a hard crust which sticks to the glass and it is difficult to remove. Now purification of HCl. Concentrated sulfuric acid is used as drying agent. Here calcium oxide and phosphorus pentaoxide are not used as a drying agent because it reacts with HCl. As you can see in the reaction, calcium oxide reacts with HCl to form calcium chloride and water. Phosphorus pentaoxide reacts with HCl to form PoCl3 and HPO3. Now, how the gas is collected? HCl is not collected over water because it is highly soluble in water, and HCl is heavier than air, so it is collected by upward displacement of air. So this is all about laboratory preparation of HCl.
Hello friends, today we will see laboratory preparation of HCl gas. First of all, let you know that, what is hydrogen chloride? Its molecular formula is HCl. Molecular mass is 36.5. And, it is formed with covalent bond. See dot diagram or Lewis structure and orbital diagram of HCl molecule. In animation. In laboratory, hydrogen chloride gas can be prepared by reaction of concentrated sulfuric acid on sodium chloride. For the preparation of HCl gas from a salt, we need reactants, sodium chloride and concentrated sulfuric acid. We need apparatus like flat bottom flask, thistle funnel, burner and beakers. Now, let us see procedure. Set up the apparatus shown in the animation. Place a common salt, like sodium chloride, in flat bottom flask. And pour concentrated sulfuric acid through the thistle funnel. A rapid evolution of gas occurs and when the mixture in the flask is gently heated, and HCl gas is evolved. This HCl gas is again passed through sulfuric solution for drying. Now, this dry HCl gas is collected by upward displacement of air in the jar. Since it is 127 times as heavy as air, and is very soluble in water. C. Reactions take place in the experiment. NaCl plus H2SO4 is heated on 200 degrees Celsius. It gives NaHSO4 plus HCl gas. This reaction goes continuously by evaluation of HCl gas, and it can occur up to the stage of formation of sodium sulfate by heating NaHSO4 plus NaCl at 200 degrees Celsius. Note that this is a reversible reaction.
We are going to study properties of hydrogen chloride. Hydrogen chloride is heavier than air and it is highly soluble in water and acidic in nature. Now in this experiment of HCl heavier than air, a jar containing candle, on that we take a glass jar filled with dry HCl and place it above the candle. HCl is heavier, so it extinguishes the candle. It forms a layer over the candle and it cut off the supply of air. HCl being heavier, it goes down. So this experiment proves that HCl is heavier than air. For fountain experiment is used to find the solubility of HCl and its nature. Now, as you all can see in the diagram, it consists of inverted round bottom flask filled with dry HCl gas. It has stopper with two holes fitted with jet tube. Dropper is filled with water. One end of the jet tube is in round bottom flask while other is in the solution. Now when we press the dropper, water is filled in the flask. HCl is highly soluble in water and so it dissolves in water to form hydrochloric gas. Vacuum is created due to the difference in pressure. Pressure outside the flask is much more than inside, and so the blue litmus is sucked inside the solution and then it turns red.
Fountain experiment to show high solubility of gas. Take a dry round bottom flask and fill it with dry hydrogen chloride gas. In the mouth of the flask, fix a rubber stopper with two holes. Through one hole, pass a long jet tube such that the jet tube is close to the base of the flask. Through the other hole, pass a dropper half filled with water. Clamp the flask in an iron stand. Place the beaker containing blue litmus solution under the jet tube. Press the bulb of the dropper. It is seen that the blue litmus solution rises up in the jet tube and issues out of the nozzle with great force. It strikes against the base of the round-bottomed flask and spreads in the form of fountain which is red in color. Vapor density. Its vapor density is 18.25 and that of air is 14.4. It is 1.28 times heavier than air.
Here a special funnel arrangement is used for preparation of HCl. Because if we use delivery tube, the delivery tube is delicate and so it may break. So to avoid this, special funnel arrangement is used. In this, the funnel is kept in such a way that the rim of funnel is in contact with the level of water. HCl is highly soluble in water, so little bit of water enters and level of water fall down and it forms hydrochloric acid. Now, what is the reason behind this special funnel arrangement? It is used for avoiding back suction, and second thing is it provides large surface area for absorption of HCl. So there are two reasons: prevent back suction of water and provide large surface area for absorption of HCl.
Hello everyone. In one of Nerdrage's videos, he uses a backflow preventer to keep his newly made hydrochloric acid solution from being sucked back into the reaction flask due to the high solubility of HCl and due to the pressure change from a cooling reaction flask. This backflow problem is common, and several people have contacted me asking for a video on how to prevent it without having to buy the adapter. So I decided to do a short video on just that, using common lab items. The first thing you'll need to perform this task is a funnel. I'm using a glass one, so you can see how this works, but any funnel will do. And you'll also need a beaker that the funnel can fit in, with a small amount of room free around the sides. It is important that the beaker diameter not be a whole lot larger than the funnel diameter, but you also don't want a tight fit. Last, you'll need some latex tubing. Take the end of the latex tubing and, being very careful, place it on the end of the funnel. Using a clamp, clamp in the funnel and tubing over the beaker. The beaker should have however much water you wish to use to dissolve your gas in. Now move the funnel down till the rim is just a couple millimeters below the water level. And now you're set up. Okay, let's see how this works. As pressure rises, the gas will displace the small amount of water in the funnel, pushing the water up the sides of the beaker. As the pressure continues to increase, the gas will begin to bubble out in the beaker and into the water that was displaced in the funnel. This will continue as long as the pressure is increasing. When a backflow begins to happen and the pressure decreases, the water that was displaced is sucked back into the funnel. As the pressure continues to decrease, the funnel takes up all the volume of water that it can and then starts sucking in outside air, equalizing the pressure. This continues as long as the pressure decreases. This works because the volume of the funnel is greater than the volume of the water the funnel is immersed in. As you can see, there's no way for the water to get sucked back into the reaction flask with this setup. The only downside, of course, is if you're trying to keep outside air from entering your reaction. Okay, so here we have the complete setup with a gas generator attached. I'm going to make ammonia and bubble gas through the ice water. Just like before, you'll see the water getting pushed out, followed by a lot of bubbling. Then, when the reaction is done, the water gets sucked back up the funnel. Then outside air is pulled in, equalizing the pressure. I hope this video is helpful, and as always, thanks for watching.
Properties of HCl. Now, whenever HCl is dissolved in water, it forms hydronium ion or H plus ion along with Cl minus. But in organic solvent, it does not form any ion. Now, let us study the typical properties of dilute acid. Metal reacts with dilute acid to form salt and hydrogen. For example, magnesium reacts with dilute acid to form magnesium chloride and hydrogen. Base reacts with dilute acid to form salt and water. For example, copper oxide reacts with dilute HCl to form copper chloride and water. Ammonium hydroxide reacts with acid to form ammonium chloride and water. Metal carbonate react with dilute acid to form salt, water and carbon dioxide. For example, copper carbonate react with dilute acid to form copper chloride, water and carbon dioxide. Metal bicarbonate react with dilute acid to form salt, water and carbon dioxide. For example, sodium bicarbonate react with dilute acid to form sodium chloride, water and carbon dioxide. Carbon dioxide turns lime water milky. Potassium permanganate and potassium dichromate, both of them has no effect on CO2. Metal sulfite react with dilute acid to form salt, water and sulfur dioxide. Metal bisulfite react with dilute acid to form salt, water and sulfur dioxide. Sulfur dioxide also turns lime water milky. Metal sulfide reacts with dilute acid to form salt and H2S gas. Metal sulfide, let us consider iron sulfide reacts with HCl, dilute HCl to form iron chloride and H2S gas. H2S gas has a smell of rotten eggs. Whenever silver nitrate reacts with dilute HCl, it forms white PPT of silver chloride and nitric acid. When lead nitrate reacts with dilute HCl, it forms white PPT of lead chloride and nitric acid. So these are the typical properties of dilute HCl. Now concentrated HCl act as oxidizing agent. Now whenever oxidizing agent reacts with concentrated HCl, it forms salt, water and chlorine. Manganese 4 oxide react with HCl to form manganese chloride, water and chlorine gas. Manganese 4 oxide is black in color, which turns to greenish yellow chlorine gas at the end of the reaction. So this is about the oxidizing agent HCl. Now there are 3 tests for HCl. Silver nitrate reacts with dilute acid to form white PPT of silver chloride and nitric acid. Ammonia reacts with HCl to form dense white fumes of ammonium chloride. Manganese dioxide reacts with HCl to form manganese chloride, water and